Okay. Right. Let's now that we are set up, let me give you a brief intro into what this session is going to be. Even before that, let me give you an intro about myself. Or probably you guys don't know. My name is Anil. I'm a DevOps cloud architect. My specialization is in terms of providing what is called developer experience. Let me write it down. Size. This is what I specialize in. Means even though I'm a cloud architect and DevOps architect, I work mostly with developers, and nowadays especially with Java developers. Java is the most popular programming language even now. You all know that, right? So what I do is I have about 18 to 20 years of experience. What I do is basically, let me give you a picture of this thing so that you get a hint of why this session or how this session can be more helpful for you. If you see this image, this is basically the expertise I have. Our current working area is towards the left side of this diagram. So this part. Just a minute. Just give me 1 minute. I missed that app somewhere. Right. So here, if you say this is the part that all of the developers are usually interested in. This is where you plan your application, you code it in your Java, then you build it using your tools, Maven or Gradle. Then you send it for testing, your unit testing and other stuff. Then you eventually release. So this diagram that you are looking at, this is the whole dev and operations thing. Out of that, the left side is what your part as a developer is. And this is where my expertise is in. I specialize in working with the developers in setting up tools like Git, Maven, Jenkins. These are the tools that you will need to write your code and to push your code to the user. So what we are talking today is this part, the Git. After writing your code, this Git is probably the most important tool you would be using. When you write your code, you need a tool called Git. We will see what Git is, how we use Git, and why it is important in a moment. So we're going to, in this DevOps MS, we are talking about one of these tools, Git, and a related tool called GitHub. So this is GitHub is another related tool. They are not same. We will see the difference, and we will try to understand how your Java development needs GitHub. Let me go into what is Git. Then you guys tell me whether we need Git or it's an optional one. All right, in the next 15 minutes. First, I'll tell you what Git is and how it's related to your Java development. Some of you said voice is not clear. Is it okay now? Voice okay? There is a voice lag. If there is a voice lag, if the first thing, please try your bandwidth. Voice lag is the most common root cause for voice lag is your bandwidth. Please try it out. Let's get back to what is Git. I would say even before that, forget Git for a moment. Don't worry what Git is. I'll tell you a story that you are familiar with, most of you. You've written a love letter. Did you try writing a love letter? Try to recollect. No. Okay. Did you write a message, a love letter kind of message on your WhatsApp to somebody? No. You finished your college and you did not try to write a love letter yourself. Try, not give it. It's okay if you haven't sent the message. It's okay. But did you try sending a message? A love letter kind of message. Yes, no. So we're talking about, not talking about Git. We're not really interested in technology. Sunday morning, it's a boring topic. We're talking about writing a love letter. Anyway, no love letters, only WhatsApp. Yeah. The digital love letter, let's say. Probably, you must have written some message that you wanted to send to somebody you like. Instead of calling it love letter, let's call it a love message. Did you write a love message? Take your time, say yes or no. It's okay. You tried writing, right? Sometime in your college. We all tried it. Now go back to that day. Yeah, we can try it even now. You're still young, that's fine. Go back to that day and imagine the process of writing. Don't worry if you have sent it to somebody or not. Leave it. Visualize the effort that you put into writing that message. Let me take an example like, hi. Can you hear me? We lost it. One moment, guys. Hello. Those who are online, just give me 1 moment, guys. There's a problem with volume here. Sanjay, let's shoot. Connection ఏమైనా పోయిందా? ఇవ్వనా? ఓకేనా? ఏం జరిగింది? All right, guys, sorry about that. So we're talking about a very interesting topic, lovelets. Lovelet. All right. So go back to the day when you tried to write that love letter or love message. Question number 1. Did you get that actual love message on a single go, or you tried it once, then you tried to change the wording, you tried it second time, you tried it third time? How did it happen? When did you get the perfect message? First try, second try, 10th try? After 2-3 times? Yeah, I think after 2-3 times, then you're really good with the writing messages. I never got it after second time. I had to wait for 1 week to get the correct. Still, I could not send it, but that's another problem. So writing a message, let's say after many trials, yes. So we all know when we are writing anything, when you are creating anything, it never happens in the first. So one interesting thing that we all tried, and probably some of us got it correct, is a love message that you wanted to send in your WhatsApp. The noise was listening. Okay, let's try. Right? Now let's say you got it after 10 trials, you got a perfect message. Now during these 10 tries, or at the end of the 10th trial, you started thinking, maybe a previous one was better. Let me write some messages here, just to get an idea of how probably this would turn out. We're trying to write a love message to somebody you like. This is the best way to understand Git. All right, so I tried first time, try 1. Hi, I didn't like the address. Try 2. Okay, give me some ideas here. Hello? Starting? I didn't like it. This is just like, talking to friends. No. Strange. This is more like a resume, not like love message. Dear. Yeah, that's a good try. Somebody said dear. Yeah. voice.
చెప్పరా బాబు టాపిక్ లోకి చూద్దాం చేస్తున్నాం. ఎయిట్ 40 అయింది, ఇంకా 20 minutes లో క్లాస్ స్టార్ట్ అవుద్ది. అడగమాక అంత టైం అయిపోయింది. త్వరగా కానీ
Guys, those who are online, give us a minute. There's a slight problem here with voice. We're trying to fix it.
రాస్తున్నావా? తీసుకురాస్తా డాట్ పై డిస్కప్ వేసిందా కానీ పరిగెత్తవే. 8:40 నువ్వు తినే టైం ఉంటుంది మళ్ళీ. పైకి అదిగో అదిగో ఇక్కడ.
Rajkumar, mute yourself, please. Rajkumar, mute yourself.
Okay, let's get back to our 10 tries of writing our message. We're on the third try. You got the exact same problem when you were writing. Nothing actually worked out for us. Hold on. Okay, let me just write it down here while you can look at it. Try 4. Any new messages for try 4? Can you hear me without this thing? Hello, dear. Try 5. Anything on try 5? Darling. That's good. Somebody said that. Online recommendations, sir. There are a lot of creative suggestions here. There's another thing coming up. 6 thing, try 6. Yeah, come in, please. This is another recommendation coming from online. Hi, cutie pie. Okay. Try 7. Okay, probably some of these things you like by now. All right. You started to like some of these addresses. Initial message you are talking. You said you started with hi, try 1. Then you moved on to hi is very, very extremely professional. Then you moved on to hello. Then you said, okay, let me call dear. Then hello, dear. Then you're getting more creative, darling. Then hi, cutie. Somebody else said sweetheart. Okay, that's good. Okay, this is another recommendation. My sweetheart. Okay. By the way, this applies to everybody, huh? Both male, female. It's nothing specific to one gender here. She will block you right away. Yes, it's possible. It's possible. That's a possibility. You will get blocked. Now, couple of other tries. Couple of other tries, guys. Anything else? Okay, let's keep it this up to this. Now, by 7, you got some multiple ways of doing the same thing, right? Now, let's say when you are at 7th try, you thought, okay, this probably is not too good at this point. You wanted to dial it down a little bit or tone it down a little bit and say, let me choose hello did. Means you don't want to go use the last try. You wanted to use something that you have written earlier. All right. So the first time when you tried to write something, it became your first draft or first version. This one. The second time, this is second version, let's say. So let's call it V1. Second one, V2. Like that, you started with V3. So every time you change something in your writing, it is becoming a new version. Now you went on like that. You went ahead and you wrote some other things that you want. Now at some point of time, somewhere at 7th point, you thought, okay, this is not really that good. I want a previous one. In this case, version 5 you want. Now imagine you did not save these tries anyway. While you are writing, you're just writing on a single page. Let's try it on a notepad. All right, I'll bring down that image here. All right, this was our try. Now let me try the same thing on not all the versions here. This is not how you're going to write a message anyway, even on WhatsApp. Let me try a simple notepad kind of. So this is a notepad plus, like your notepad or some other editor. So let's say you're starting, hi, is how I would start. I did not like it. Hello. I did not like it. You can see that, right? You can see the messages. Okay, let's put it here. Hello. I did not like it. Then there, the third one you said, hello, something else. What is that? Something else. So something like this. So what is happening here is when you are trying something new, you are getting rid of the old one. You don't have any track of what was your second or third try. Yes or no? You're not storing anything when you're writing things. You just try, then you backspace it, then you come back here, then ABCD or oh my dear, something you are trying, but you don't remember what was your third try. Let's say by the time you reach the last try, hello, my dear ABC, then you started liking your third try. Let's say this is the 10th time you are trying. Try 10. You did not like it. Then you wanted to recollect, what did I try? Try what? What was my try one you tried? You're trying to recollect. Can you recollect what was your try one, try two, try three? You can't remember, obviously. Or if you have to remember these things, you have to store every try somewhere. Yes or no? For example, if I have to, let's say this is my first try 1, store it. I said hi, save it, Control S. Somewhere I'm going to save it. Temp folder. So I'm going to save it in this. So this is going to be my try1.txt. Then I open a new file, do my try2, right? Save it. Try2. So I have try1 here, try2 here, each one in a different file now. But when you're writing a big letter, can you store these versions like this? Try1, try2, try3, like 10 tries if you are saying. Everybody is able to see the screen, those who are online. Yeah, looks like there's a problem somewhere. Fine. So what we are saying here is, if you have lots of versions of something that you are doing, tracking them is a problem. Tracking them is always a problem. Now, will you have the same problem with code? If you write your code, do you see it? Do you think you will have the same problem with your code? Let me write some code in your Eclipse. So I'm going to open an Eclipse interface here. You're all familiar with this interface, right? So let's say we have a couple of projects here, just a Hello World project. In the Hello World project, I have a simple class file and a source is visible. I'm here on the left side bottom. Watch it here. All right, so come back here. So this is my welcome class. So let's say this is the class I have written. Very simple stuff. Just a println statement, nothing else. Let's say I did not like it. Instead of saying hello world, I wanted to say hi world. All right. So that was my first try, second try, then third try, and this I did not like. Hi everyone, I wanted to say. So I'm changing my code multiple times when I'm writing. That could be for whatever reasons. Maybe I just did not like the println statement, or maybe this was wrong when I wrote it first time, or I wanted to change the logic of writing this. For whatever reasons, my code writing is always in this model. Try 1, try 2, try 3, try 4, like that. Isn't it? Your code writing is no different than writing a message that we tried earlier. Which means if your code does not work on 10th try and you thought one of the earlier tries was a good one, a correct logic, do you want the 5th tried code or not? Agreed? Can you understand what we are talking here? When you write the code, especially software code, you don't get it in the first go. Nobody gets it. Senior, super seniors, rocket scientists. Nobody gets your code first time. Someone says memory usage. No, we're not talking memory usage. We're talking stored code. Every time you are saving the code. For example, if here you saved this already. This is your next version. Your old version is gone. It's not there in the memory. The file that you saved will have only the latest version. So in software, every day when you write your code, you're always changing your code. Every minute you are changing your code. And this is not just for software. This applies to anything that you are writing or any product you are developing. Some of you may have done some projects in non-computer science. Let's say you're a mechanical engineer, all right, probably, or you're an electrical or electronics engineer. You designed a board or a room kind of thing. You didn't get it in the first go. You tried it, you got your version 1. Probably it worked a little bit. Then you got your version 2. Then you got your version 3. So any development happens, try 1, try 2, try 3, that's how it happens. And most of the times, we always go back and try to get something from our previous tries, like this. You wanted something that you written earlier. You don't like the latest one. You don't like the latest ones. You wanted something previous, which means you always have to store everything that you are writing. Yes or no? You agree or you don't agree? You always have to store what you are writing, always, because you don't know when you will need it back. Even though we are talking about these messages, the more appropriate one would be your Java code or your Python code or your .NET code or your C program, anything that you are writing, especially in software. You always need all the versions of the code that you are writing. And this is not happening just now, right? From the beginning of writing books. Let's say you are a writer, you write novels. You'll get it during the first time. Will you get it during the first time when you're writing a novel? Let's say you're writing a simple novel, a story. So when you're writing a novel, you get draft 1 first. You make corrections, then you get draft 2. You make corrections again, you get draft 3. This is a novel you're talking, or a small story that you have written. While you are writing these things, you make mistakes. Let's say in draft 5, you made a mistake, or you did not like how the story came out. You wanted to use the way it was told in your draft 3. Which means you should have your draft 3 also somewhere stored. Then only you can compare your draft 5 with draft 3. Otherwise, you cannot. So what we're trying to do here is, we're trying to understand how the software development normally happens. And what kind of tool we need to effectively develop your software. Now imagine you are developing software over a period of 6 months, 1 year. Will you remember what you did during the first month? Not possible at all. By then, you did not even understand what the project was. You were just doing some copy paste. Stack Overflow or Google or some other ones. By the end of first year, you realized, oh, this is what I wanted to do. My first month, whatever I did was garbage. So you have to go back, look at the code, get the nice pieces of your code from that time to the current code. That means you need to have that code somewhere. Can you store it in your Eclipse, all the versions? All of you are familiar with Eclipse, right? Most of you are Java developers. If you are Python, PyCharm,
So
or any programming language, VS Code.
Yeah, I'm Node.js developer.
Node.js, cool. So you should be good with VS Code. You're doing VS Code.
Yes, yes.
Fantastic. So any IDE, it basically does not do anything. It does not store anything. Versions, it does not store. It simply allows you to write the code. The storing happens on how you want to store it. So here, what we are trying to understand here is, when you write all this nice, beautiful code, you need the versions to be stored. One way to store these versions is you can create a nice file, a different file every time you change something, like file 1, file 2, file 3 that we tried here. Try 1, try 2, try 3. Those are multiple files. All right, but storing it like this is difficult and you cannot compare at a later point of time. So any software development requires that all the tries that you are doing are stored. And this process of storing and tracking these drafts are otherwise called as versions. So you have version 1 here, version 2 here, version 3 here, V4, V5 like this. Now this version by version thing is called version control systems. So we're talking about something called tracking each of your systems, version control system, popularly known as VCS. So you need a tool that can store all the drafts. Some do. You should be able to go into that tool and look at all the versions, compare all the versions, and pick up something that you like at a later point of time, whenever you need. So we're not just talking about a simple storage. We are talking about a tool that can give us control over how this versioning thing is happening. 1, 2, 3. Now, this VCS, version control system, is the tool that can give you that. Now, these tools existed before. There were earlier also, such tools were available. The latest such tool is what you are looking at, Git. There is no full form for Git. It's just a word. Git is something like, if you go into Google, it's an English word, an unpleasant or contemptible person, means a not very pleasant person. That's what a Git is. There is no full form for this thing. This is not an abbreviation. Not like the VCN thing that we are saying, version control system. The same way, there is nothing for GIT. And GIT should not be usually written in capitals. Capitals, we assume that there is something, right? GIT, there's no such thing. All right. Now this Git was introduced by the same guy who created Linux. When he was creating Linux to track the creation of Linux operating system, Linus Torvalds. Later it became very popular for all the developers, but he also used it for development only. So Git, this is something that you have to remember. Git is a simple word, basically something that is not very pleasant. And this is the most popular version control system at this point of time. Now, what we are trying to see here is how Git can be used for your Java development or your Python development or anything. And how you can integrate Git with your Eclipse IDE or some other IDE. Now, question here. Does Git have anything to do with Java or .NET or Python, any specific programming language? Or Git is a very common tool that can be used by anyone? What is it? Is Git only for Java? Or can it be used by anyone? Or let me put it in a much more. Is Git only for software? Can you track novels using Git? Global information tracker? No, that's not correct. Somebody said Git means global information tracker. No, that's not an accurate one. Git is just Git. So let's get this point straight. Is Git a version control system only for software, or others also can use Git? Let's say you are a writer. Can Git be used by a novel writer? You can. All that it does is it tracks versions. It tracks versions. So it's not Java developers or Python developers or other software developers are using Git. Even writers are actually using Git nowadays. It makes things easy. There are some tools like your IDE. They can simply use such a tool. And this tool has Git installed internally. We will see that also. And they can track draft 1, draft 2, draft 3, all their novels that they are writing. It's really easy. So it's not just you who is using Git. Now let's take the opposite side of this thing. If a novel writer can use Git, you are a software programmer, isn't it? So if a non-technical person can use Git, can you not? It should be, right? It should. The concept is same. Tracking the change or tracking a version, or in other words, a version control system. So what is a Git? It's a version control system, the fancy name for it. At a very basic level, what it does, any change that you do, it simply keeps a copy. That's it. That's how it knows it, right? It's not a very intelligent tool. Instead of you keeping a copy every time, try 1, try 2.txt, try like that, you're asking Git to do that for you. It simply keeps track of all the changes in a separate file. You will see how it does it in a moment. So Git is a version control system which can track any change. Now the most important part. Can it track only text or can it track a change to an image? Or only text? We have looked at two things till now. We looked at a novel writer, who usually writes something in English or in other, some language, natural language. Or we looked at software. Both are text, isn't it? You're looking at text. This is all text. It's readable. Now let's look at the most important point. If you're doing something in a Word document, all right, so this is your ABC, DEF, HGK. Try to understand this. So I'm trying to change this again. Instead of HGK, say something else I put in here. Change it. And I saved it. Let's see. Or let me say. So I have sample 1, which is a Word document. Earlier, try to understand the difference. This is a very key, important point. Earlier, this was a text file. Try 1, I stored it as a text file. Whereas the second, sample 1, this is a Word document. All right. Now, if I change something in the Word document, can Git track the change? So the question is, a broader question is this. Can Git track all types of changes in files? The first thing we see is text file. Can it track changes to a Word document? Can it track changes to an Excel sheet? Can it track changes in an image? Can it do that? Guys, can you guys mute yourself if you are not talking? Can I put you on?
कहाँ से? मेरे यहाँ भी लगते हैं ऐसे तो मशरूम तो घर पे ये नहीं लगते हैं आपकी क्या ये आपकी गाड़ी खुद ही ले आएगी वहीं पे अपनी गाड़ी
Just give me a moment, guys. I'm trying to put
तो फिर आप नहीं आते क्या अंकल जाते
myself.
संभालते नहीं हैं अंकल जाते तो फिर जाके फिर उनको लाने का काम देखने का आपका हाँ वो लेके आ जाते हैं वो एक दुकान डाल देंगे अपने घर का कहाँ पर
Organizer can mute. Yes, I'm not sure if I am the organizer. Muskan, are you there on the call?
परमानेंट दुकान वो परमानेंट वो परमानेंट है मतलब आपको मकान खरीद के नहीं मुझे काका अच्छा तो फिर तो बढ़िया काम कार्नर पे आगे में बैग वाला है ना, हाँ हाँ, कार्नर पे मेन छोड़ा है ये गाड़ी जगह नहीं है। अगली बार ले लेना, अभी तो गाड़ी बहुत आएंगे। कल परसों आया जाएगा अपनी गोभी वोभी के जगह, अभी पहले ये तो बना लें। वो सरसों की भाजी भी नहीं, मैं तो ले जाता हूँ वो शायद बीच में जब खत्म वो कौन सी अफीम की है क्या भैया? अफीम की है, बीच में जब से ले जाता हूँ।
Mute. It will not find mute. ముస్కాన్ ఎక్కడ తను మ్యూట్ చేయమని చెప్పు. It's a noise complaint. Can we make a
मैं तो क्या है कि जैसे बीच में अगर कुछ खत्म लगता है रहने का, तो मैं 10:30 11 बजे 10:30 क्या 10 10:30 बजे आता हूँ यही और ले जाता हूँ, और एक ही दुकान से इसी के यहाँ से 5 मिनट में फटाफट घर। बस एक्चुअली सब कुछ सॉर्टेड है ना, इसलिए इसमें अगर आप देखोगे तो छाटने की जरूरत नहीं पड़ती।
questions?
Nitesh
Just 1
Pathak.
minute, guys. I'm trying to find out who the person's left that
Nitesh
open.
Pathak, can you please mute yourself?
Now.
You're
Yeah.
buying vegetables.
Anil, yeah, I think we are good, guys. Okay. Yeah, I think we are able to sort it out. Yeah. Sorry about that thing, guys. So let's come back here. We're talking about the Git's ability to track not just text, but other forms of files. Word. We want to get into the actual thing, guys, quickly. Let's try to quickly understand this. Can Git track changes to the Word document? What do you think? It can or it cannot? It can. And an Excel sheet? Correct. Which means from a software perspective, means theoretically, it should be able to. All that it is doing is, even for a text file, it's storing everything. But for Word and Excel sheet, these two softwares are usually, these two are owned by Microsoft. And the technology that you use to draft this text is proprietary. It's not given to outsiders. So Git does not really know, or it's not at least designed at this point to track anything other than text. This is the most important understanding you have to do when you start using Git. If it is simply a change that it can track, it should be able to track change to Word documents, Excel sheets, anything, but it cannot. Since Git was not enhanced or not integrated to track a Word document. A Word document stores data in a format only known to Microsoft. The underlying technology of how Microsoft works or Microsoft Word document works is not known to anybody. It's not open source. So Git tool cannot know how the changes need to be tracked or how it can be stored. So for now, just remember that Git can track only text. It is not even enhanced or reached a stage where it can track changes to the images. Let's say this is an image, right? I can take an image of this thing. This is image 1. Let's say I'm taking an image, capturing it, screen capture. I'm using a tool called GITHUB. This is a nice tool. I can simply take an image. This is an image, all right? Let me store this image. This is image 1. Image version 1. Now I make some changes to this image. All right, I've added another word here. Sorry. Where are we? Yeah, that's why I add another one, new word or new format or MP3 file. Let's say there is a change. Can it track changes to the MP3 file? Probably not. So this again, I am taking another image here. If these two images, we give it to Git, it does not know any difference. It cannot identify. So all that Git can do is track only the changes to text. And because most of the code that we write is text format here, your Eclipse is all text, only text. So Git can track only text. Now the next question, an enhancement to this thing. Can Git track .class files? With this same logic, can Git track .class file? Class file is a compiled version of .java file, isn't it? So .java is your pure code. This is where you are writing your code. This is where you store your code, .java. Then you compile it using Java 3. That's when you get a .class. And you bundle such .classes, you get a .jar or probably a var or near, depending on what code you are using. Now these are compiled formatted files. Can Git track these files or just .java? It's already compiled, so Git can only track text at this point of time. So you do not track your jars, vars, ERs using Git. You cannot track changes to a MP3 file, or you cannot track changes to a Word document. You cannot track changes to an Excel. So do not try to do these things with Git. It was kept at a very simple level so that it can do the job very efficiently. So all that Git does, or only thing that Git does is it tracks changes to the text files only. The code has to be text. All right, so let's come back now and try to see what we are going to see in this session. So we're going to have 3 parts of this session. So far, we've understood what is Git. Then we'll try to understand what is GitHub and how it's related to Git. And then we will see how to use Git plus GitHub together. And towards the end, we'll see how this whole thing happens in Eclipse. So that you have an end-to-end flow of these two tools and the most important things in these two tools related to your specific work. Right now, we learn the theoretical part of Git, means what generally Git is, and this is very important. If you don't understand what is Git, the same way, what is GitHub, you will not really be able to use it efficiently. Now that we know what is Git, let's try to get the technicalities of it. So what is Git is a version tracking system or version control system. Some people call it version tracking system also. That's also fine, but the approved name is version control system. And it tracks only text. That's it. Now let's see how it actually does that track. So if you have to track something on your system, now remember, so far we are not really talking anything about the GitHub part. We did not even touch it. Let me go back to the first image where we started the day with. You see this thing? Your very first image, Git is not GitHub. They're two different things. They're two different things. So far, we've been talking only about Git. And we know by now that Git is used to track the changes and track the changes of text files only. It could be English, it could be Hindi, Telugu, anything, or it could be Java, Python, .NET, anything, but only text files. Means your .java files only. If something has changed in your .class file, it does not know how to track it. Or something has changed in your .jar file, it cannot do anything to help you out with. So Git is for text tracking in our specific case, Java code tracking or Python code tracking or code tracking, software. We are talking software. Now Git and GitHub are used together. We will see that in a moment, how they can come together and help us better. For now, Git is for version tracking system. I keep repeating the same thing because these are the most important things. Once you understand the basics or the core important points, using the tool is simply click, click, click kind of thing. Using the tool is not really that difficult once you understand why you are using it. So Git, so far, we realize that it's for version control, tracking the changes. Now let's go ahead and quickly see how it does it. So you install Git on your laptop or any system, Windows or Unix. That's the first thing. Let's go ahead and quickly try to install Git. So download Git. I already have it on my system. You can install it on your Windows or on Linux. This is another important thing. Now, you being a Java developer, you will be working either on Windows or on Linux most of the times. Windows, because you're in India. If you move out of India, you will get a MacBook and you try to do it on Mac. But right now, Windows is perfectly fine. So you can install Git on Windows or Linux. For now, we will stick with Windows because this is where most of your development happens, right? So Git, let's download it. This is download. I'll click on Windows here. You get me a 64-bit Windows setup or a 32-bit. I don't think 32-bit anybody uses anymore. Windows 10 is 64-bit only. So most of you are using Windows 10. So it will be 64-bit Windows setup. So once you download it, click on this thing, You will get an exe file just like any other software. This part is really easy. There's nothing really complicated about this. Watch out here. This is where it's getting downloaded. Left side bottom. So let's say it got downloaded. That's very slow. Give it a minute, see if it gets downloaded. Otherwise, we'll stop it. So we're trying to install Git on your local laptop, Windows now. It's actually downloaded. So here, you got your Git. You can see it here. This is your installer, the .exe file. If you double click this thing, it will give you the generic installation steps. This is how you install it. Nothing too complicated about this thing. There is something called Git bash. See this thing here. This is a command line tool for Git. Just like what's the command line tool for Java? Java C or Java, one of these things, right? The same way, Git also has a command line. It's called GIT. The command name itself is GIT. We'll see it in a moment. So let's see if you using bundled OpenSSH, select the default options, default again. It goes ahead and installs Git. I've already installed Git on this thing, so I'm going to cancel it. So once you've finished your Git installation, you will be able to execute your Git commands. So you go to your command prompt, you try to execute Git. It did not. It's not in my path, I think. No, it's not in my path. Let me install it again. Or let me use another code editor. This is VS Code, another editor, just like your Eclipse. This is a terminal. This is how a Git command works. Even this is not working. Sure. I think I messed it up yesterday night when I was trying something. No. No, it all messed up. Let me try to install it again. Fix it. So I'm going to install Git again. We just now downloaded this time. So go ahead and finish your installation. Next, 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 next. I'm using all the default values here. Git bash is a CLI, a shell that gets installed on Windows. We'll see Git bash in a moment. Hold on. Yeah, we will see how to use Git in a moment. Just give us a moment. So try to install Git and set it up locally. You see this thing, when you install Git, it also installs something called Git bash. You see this thing here? I can't increase the font size. Git bash. Git bash is basically a Unix-like shell installed on Windows. So we will see Git bash in a moment. So I'm going to launch Git bash after I finish this thing. You see this thing? This is your Git bash. Leave this thing, or this one, this window. Can I increase the font size? No. Can you see the font? No, it's better. All right. So Git, you see, it actually executed a Git command, GIT. This one, Git. You see, this is a Git command with all the options. These are all the options of Git command. So we will see some of the important commands of Git in a moment, like Git clone, Git init, Git add, all right, Git branch, Git commit. We will see those things. Those are the most important commands. There are about 10 Git commands that you have to know as a developer, and that will be more than enough, even though there are a lot of Git commands. So this is a command line model of running Git. So what we have done so far is we understood what version control is. We'll take a break, just give me a moment. Huh? So let me just summarize what we have done so far, so that while you go grab a coffee, try to recollect everything that we have done so far. That's really important. So here, so first thing, we try to understand why we need to track any change. Any change that you are doing. You started with your love message, then you started about writing a novel, then we started talking about your Java code or Python code that you write. So we understood that we have to track any change. And this tracking process, what is it called? Version control. And you need a tool to do that, a system to do that. Version controlling is tracking the change. And the tool or the system is the version control system, very popularly known as VCN. There are VCNs earlier also, but the most popular one nowadays is Git. So Git can track only text only. This is an important thing. It cannot track something that is non-text, like an Excel sheet. It cannot track. It does not know how to interpret Excel sheet data. Or an image change, it does not know anything about how to interpret images. So it was kept at a very simple level at this point of time. So Git to track text, and then we have seen installation of Git on Windows. We have seen it can be installed on Linux also. If you're working on Linux, that is also a very simple process. For now, we'll stick with Windows. Then what's the command for Git on Windows? Git itself, and you run it in a shell called Git bash. We just now launched it. This is what Git bash shell is. See this thing? You can launch it using Git bash. After your installation, this is how the tool looks like. You can launch it just like a command line that we normally do on Windows. So once you have this Git bash, you can run Git commands on this command prompt. All right, I will take a break. How long you need a break for? Really? Man, that's lunchtime. Really, you need half an hour?
Huh?
Okay. Okay, I don't think I can stop you anyway. You won't come back. So it'll take half an hour. 9:45 now. We'll come back by 10:15. What? Sorry? 10:15. Okay. Don't have your lunch now. We'll finish it before lunch. All right. Lunch is after. The duration of the session, we are planning on finishing by 1 o'clock. If you guys are okay, and if you are too tired, we will try to finish it by 12:30 around. Sunday, right? I understand you are not interested, but you're interested in job, right? This can get you a job. So we'll try to finish before lunch. All right, promise. So we'll take a break now. 9:45. We'll come back by 10:15. And when we are back, we'll try to see some important Git commands. After this session, means by the end of today's session, I want you to remember at least the 5 most Git commands, most important Git commands. Git init, Git clone, Git add, Git commit, Git push, and Git pull. That's it. That's all Git is about. You're an expert at Git by that time. All right. We'll talk about those commands once you're back. So I'll see you again at 10:15. Thank you very much. Those who are in online, guys, we'll take a pause. Let's get back by 10:15. Muskan చెప్తానికి ఇది స్టాప్ చేయాలి. that thing in your mind. That's really important. So git init, that's the first command. Then git add, or even before that, let's go logically. Git status, git add, git commit, git push, git pull. There are a couple of other miscellaneous commands. Git branch, or git checkout. We'll talk about those things later. For now, let's stick to this thing. So these are the 5 commands: init, status, add, commit, push. Make sure you remember these commands and make sure you're able to say these commands really quickly when somebody asks you about Git. That actually increases your confidence. For example, let's say somebody asks you, what do you know about Git? The moment you get that question, immediately your answer should be all these 5. Init, status, add, commit, push, pull. Done. That's all Git is about. Now we will see what each of these commands mean and how Git stores or tracks your data, or what Git does when you execute any of these commands. The first one, git init. Git initialization. You can see it in the this thing. So you say git init. What it does, initialize an empty Git repository. That's what it does. Instead of theory, I'm directly going ahead with the command so that you understand it better. So what you did when you executed git init command, it initialized a repository. Let's take the word repository. What is a Git repository or any repository? Let's try to understand this thing and try to get rid of that word. You will come across this word again and again. Repository or repo, very common word in all software development. Repository or short form rep. A repository is like a storage, like a godown. That's what a repository is. That's where you store everything. Storage. So if you are a very simple word, folder. Folder, you usually create a folder so that you can put files inside it. Is it not? All the folders that we normally create, why do we create a folder? You want to put something inside it. So you can call this folder that you are looking at as a repository of files. Now the files can be a lot of types. They could be simple text files. They could be MP3 files. They could be MP4 files, videos. They could be PDF files. They could be a mix of all these files. So any repository is basically a group of files, storage we are talking. That would be more than enough. If you spend more time on it, it would be a waste of time. So a repository, when we say, it's a storage. Now let's get back to this word. A Git repository, what does that mean? What does Git store? It stores the files, especially text files, isn't it? That's what all Git is about. Storage of text files. That's how it keeps track of all the changes you are doing. Instead of saying text files, can I say .java files? They're also text, right? Yes. Let me show you one such .java file. We've been looking at it all through the session. This is one such Java file. Welcome class.java file. All your classes are written in your .java. If you are a Python developer, a .py file. Any programming language, you usually have a text file. That's where the code is written. This is not compiled yet. So .java files is what this repo normally should have or should track. Now to track it, let's see how Git does it. So when we did Git init, it basically created a repository in the current directory, and it tried to create a .git folder in it. Let me go to that location. C users Anil K .git. I'm going there on my system. So C users Anil K .git. Let me change the all right. Let's try to find out where our folder is. .git. You see this thing? What's the name you're saying? .git. So this is the folder that the git command that we have executed has created. Let's see what's inside it. These are the directories and files that Git uses to track your files. So when we say Git init, all these things are created. What time were they created? You can see it, 10:29. What's the current time? 10:34, about 5 minutes before. So how did we get these files? By initializing a rep. So anywhere when you execute a Git repo, which means anywhere when you execute a Git init, you are creating this directory structure. So Git creates this directory structure. And Git uses these directories, individual directories, to track all the changes to your files. We did not add any file to this repository yet. Remember, this is an empty repository. You see this thing? This is an empty repository, means our files are not there in it. Then what are these files we are looking at? These are files used internally by Git, and they're always in a .git repository or .git directory. Now let's go ahead and try to create another directory and initiate that repository. So you can have as many Git repositories as you want. So I'm going to another location. Let me go to another temporary location here. So I'm creating a folder, my new Git repo 1. This is a folder in which I want to keep my files, and I want Git to track the changes to the files in this directory. Try to understand this thing. Your Git is not tracking everything on your laptop. Just because we have installed Git, does it mean it's tracking everything on my laptop? No. We will track only the things that we need. For example, let's say I am putting some .java files in this, and I'm going to make changes to that .java file, and I want Git to track changes only to this directory. I don't want Git to track changes here, or anywhere, but only this. I need to tell that to Git. How do I tell it? I go into this directory on the command prompt, and I say Git init. Right? Understood so far? Let's go back to this directory on the command prompt. Here. What's our current directory? We are in C users Anil K. What's the directory we have to go? We have to go into D temp remove my new Git repo. You can actually copy paste this whole thing. Copy. CD. Paste it. D colon, directly go to D first. Oh. Okay, the directory structure is slightly different here. You see this? This is a Windows-based directory structure. Look at this thing. How is this? It's a slightly Linux-based directory structure. So instead of C colon, you have /C. So same way, if we want to go into D colon, we'll say /D. /D, let's say. You're in /D, PWD. You're in /D now. How did we go to /D? Change directory to /D. Let me write those commands also here. So git bash, we are talking here. It's slightly different. Remember, not difficult, but slightly different. So there's no rocket science here. You're all Java programmers here. So git bash, if you are writing, C colon is represented as /C. D colon is represented as /D. So if you have to move, you do CD, change directory to /D. That's what we did. CD means change directory. So let's go back to the command prompt. So currently we are in /D. Let's look at this command, pwd I did. Let me write that thing also. Any guesses? pwd, present working directory. Perfect. Present working directory. These are not Linux commands, guys. These are Windows commands only. pwd works everywhere. These are DOS commands. So pwd, we are currently in /D. This is called /. Where do we want to go? We want to initialize a repository, this thing. Temp remove my new git repo 1. Now you can copy paste this whole thing. Let's see if it works. Instead of colon, we have to give /D. This is /, not backward slashes. Got it? Let's press enter. pwd. Where are we now? You are in that temp directory or my new git repo 1. This is a directory name, and you want Git to track changes to the files in this directory. Remember, no, so far we haven't started anything on Git yet. The only simple thing that we are doing is we created a directory on our Windows laptop, and we are simply doing a CD to that directory. That's what we did. And after doing a CD, we made sure we are on the correct directory. How did we make sure? We checked the current directory, our present working directory. No rocket science here. Pretty simple. Now, what's the next step? This directory, this present working directory, let's clear it. I want to make this directory a git repo. How do I do that? Git, your first command, init. So whenever you execute git init, the current directory, which is this thing at this point, it tries to convert into a git repository. And during that conversion, it creates one specific directory. What is that directory name? .git. Perfect. So when you are doing a git init, you are actually creating, or you are asking git command to create a .git directory, and inside that .git directory, we have a specific set of files. We will see those files in a moment. Let's execute the command for now. Git init. So this is going to initialize this directory as a repository. Now, does this directory has anything in it already? Any files? No, this is an empty directory. So when you ask Git to convert this directory into a repo, so it's going to just create an empty repository. So it's saying there are no files in this directory. So I am not tracking anything at this point. All that I am doing is creating the structure. That's all. So let's go ahead and try to execute the command git init. What happened just now? It created a .git directory. Can we see the contents of this directory? We did that earlier. Let's go back to this location, .git location under my new get repo. Remember one thing, guys? This structure of these files is slightly different. So when you execute commands, you give a forward slash. Whereas when you receive messages, it still says D colon, but the D colon you will usually refer to as /D. That's a slight difference. This is coming from the original DOS thing. So let's go to this location here, the .git, and try to understand how a get repo looks like. So let's go back. We're here, you see this thing? This is the directory. We tried to convert this directory into a Git repo, and it has created a .git file in directory in itself. So let's go into the .git directory, and this structure is a standard structure, which is created just now. You can see the font, right? Yeah. So this is the directory structure of any Git repo. All right. You can see the same list here on this command prompt also. What's our present working directory? Learn to get comfortable with this Git bash, guys. That's the reason I'm showing everything here also. If you are comfortable with Git bash a little bit, it will be a lot easier to work with Git. And also, it will be a lot easier to understand Git. So this thing here, your current working directory, your present working directory is here. You want to see the contents of it. The command to see the contents in Windows is dir, nothing is shown here, or list, ls, ls-a. You see this thing? A normal dir or ls command does not show anything that starts with git dot. The reason is anything that starts with a dot is called a hidden file, even on Windows. See this thing here? If you go back here, I think you guys are going to have a problem when you do this thing. I have selected this hidden items here. You see this option? Unless you select this option, the .git will not be visible to you. Let me unselect it. You see? So what are dot files or dot directories in Windows and Unix? They are hidden. So if you create another file, let's say here somewhere, let's say here, I'm creating another file, dot hidden directory. It applies both for directories and files. So I've here. Can you see the directory? Where is it? Oh, I can see it. Hold on. Should not be visible, is it? Should not be visible ideally. Let's mark here. This is the directory that I'm working, folder 1, folder 2, my git repo 1. You see here, this is the same directory that we are looking at, right? Here, the dot file is not visible. Interesting. Let me close it. Reopen the directory. We're trying to see if dot files are visible or not. So D, temp remove. I can still see it. It should not be visible. Anything that starts with a dot should not be visible unless you have this option enabled. But it's still, I can see this file. Either I have not created it properly or something is wrong on my laptop. We'll fix that later in a moment. Let's say this. Let's come back to this thing. Where is your .git directory? It's still there, but your options do not allow to look at hidden files. So here you enable that option. Then you are saying this is the most important thing. So it's under view. This is what normally opens up. You go into view, you select show hidden items also. And inside that, you have this. All right. So your Git repo is initialized. So this is your Git repo, my new Git repo, clear it, clear CLEAR, ls. Nothing is visible, ls-a. cd to .git. ls is a list command, guys. It works in git bash. Let me write this down also, this command. This is the third command we are working on git bash. ls hyphen all files, list all files. That's what hyphen a is for. List all files, including hidden files. What's a hidden file? Anything that starts with a dot. That's a hidden file. You will see this problem in Java also when you are deploying your applications. A lot of times unknown hidden files will be there and they'll prevent the Tomcat server to load the pages. It's a very common cleanup thing that operations people do. So make sure your repositories do not have hidden files. And the way to do that is, if you are on Windows, you will make sure this is enabled. And if you are on a Git bash, you can always do a ls-a. All right. So you are on .git at this point. Or do you list all the files? ls-a again. So these are the same set of files that you are seeing here. All right. So get used to both your Windows and Git bash. Git bash is not Unix, remember? This is also Windows, and you should be comfortable with this. So what we have done so far is, we have initialized one directory into a Git repository. And the way we did was by doing a git init command. And when we did a git init command, it created the .git directory and all the files inside it. The same files are visible here also. So that's our first command on Git, guys. Let's move to the next command. What's our next command? Git status. What's the purpose of Git? Git is basically to track files, right? So when we say Git status, It tells us what is it tracking, what is it not tracking. You see this thing, git status fatal, this operation must be run in a working tree. Okay. You see here, what's our current location? .git. You should not run anything inside this thing. You should be at the root repository here. Let's go back to our Windows part. Let me put it in two ways. On the left side, you have Windows, and on the right, you have the Git bash. It makes more sense now. So our current location, .git, pwd, it shows .git, and on the left side, you are in the same directory. Let's do a git status. Git status cannot be done on here. You come back one step behind. cd ... It's like clicking on the parent. You're coming here. Let me write the next command here. You have two commands related to cd. Earlier, we did a cd to any other directory. Now we did another command, cd ... That will take you to the parent, or you can always use the regular model, cd/d. All right, go from top to bottom. What's the next thing? cd temp remove. We do a ls again, cd my new GitHub. Able to follow me? Or you lost it? This is the practical things that you'll be doing after the concept. Let me repeat it one more time, what I did. Let me repeat it in a slow motion. We want to go to which location? Our Git location, wherever the Git repo is there, this one, this location. D, you can see it here, D temp remove my new Git repo directory. So come back here, cd/d, sorry, cd/d, your present work directory /d, then cd to temp remove my new Git repo. It's the same directory you're in the left side. If you do a list of present working directory, you are on that directory. Now we want to find the status of our Git repository. That's our next command. What's the command? Git status. Let's see what it is trying to tell us. Then we'll try to understand. This is important. This is all concept and most important problem. What's your first sentence? It says on branch master. Don't worry if you don't understand it. We will talk about it in a moment. It says on branch master. What is on branch master? One question one. What is a branch? Question two. If there is a branch, there should be a trunk also. That's how a tree looks like, right? A branch is referring to a tree. So if we say there is something called a branch, there is also something called a trunk. And what's the name of the branch it is saying? Master. Those are the 3 points. We will write them down in a moment. Then no commit set. So there is a new word called commit. What is a commit? All right. So then it says there is nothing to commit. And it gives a tip here. Create or copy files and then use git track or something. Let's try to understand this thing. We can execute this command as many times as we want. And this is probably the most important time when you understand Git. So far, you understood what is Git. You did not understand how Git works. This is the term, Git status. So we are talking about a tree here to help you visualize how a tree looks like. Let me bring in a tree. Let me take this thing. You see this tree? You have trunk. This is called trunk. And everything around it is a branch. Let me take more easier one. Sorry about that. So let's take something that has a lot of branches. Tree with branches. This is all Git is based on this, guys. This should give you a nice idea. This thing. Out of this tree, assume this is a tree. This is a branch. This is a branch. This is a branch. All right. This is another branch. What about the trunk? This whole thing is the trunk. Can we say that? Let me change the color and show you the trunk. This is the trunk, isn't it? That's the main thing around which all these branches are getting created. This is a branch, this is a branch, this is a branch. But there is one thing that is central to the tree. We'll try to understand in a moment why we are using the analogy of a tree in a moment. Right now, try to understand what this branch structure, what is this tree that this Git keeps talking about. So here, the command that we have seen, it is talking about master branch, which is basically the trunk, this thing it's talking about. The one that is at the middle. This is called a master branch of the tree. This is one of the branches, if you consider it. And this is usually called a master, or sometimes it's called a main branch. All right. Everything else is also called a branch. You can have other names to this thing. You can call it branch 1. You can call it branch 2. Anything. But the core at the very center, which basically roots the tree to your land, is your master branch. And this is what your Git status is talking about, the command. Let's go back to the command. What is it talking? On master branch. And it's saying currently Git is tracking everything on the master branch. So each file that you are seeing here is like a leaf. So all that Git does is it assumes that everything that you are doing is simply like a leaf, and it tracks it. Is the leaf still there? Is there any change to the leaf? Are there new leaves added? Are the old leaves deleted? These are files. So it is not just tracking changes to the file. Let's see what exactly it's trying to list it out. So Git is tracking this entire list of things on a branch. In this case, master branch. So Git is asking, is there any new file or new leaf? A leaf is nothing but a file for Git. It assumes that your whole directory is a tree. So when we say, is there any new leaf? We're basically saying, is there any new file? Which means, is any new file added? That's what Git is asking itself. Then, is any old file deleted? Or is there any leaf that is lost, kind of? A dead leaf falls down. Or you delete a file, it goes away. Third thing, is there any change to an existing file? This is what we've been talking everything about. You change the code slightly. Let's go back to the Eclipse thing that you had. Instead of hi everyone, you said hi everyone in the world. You changed it. You did not delete the Java file. You did not add a new Java file. You are changing something in an existing Java. Now, Git should be able to understand that, yeah, one of the existing files has changed. So Git can track all these three changes. Let's try to do that quickly. So are we adding anything? If we add a new file, Git will know. If we delete an existing file, Git will know. If we change something inside the existing file, Git will know. So the Git status command that we are talking basically answers these questions, three questions. It gives us information about one of these three things. So let's go back and try to add our first thing. We will add it. All right. How do we add a file to a directory? Our regular stuff. So we go to that directory. This is our Git repo. We have already initialized this Git repo. Remember, it can track only if you have initialized it. You need to tell Git to track your repository. So I'm going to add a file here. Very simple stuff. So let's say new file 1. Done. There's nothing inside. It's an empty file. Let's go back to this thing, Git status. Now, if we say Git status, what is the expected output? We should get something that tells us that there is a new file added. We don't have to know the exact masses, but what should Git tell us? Why there is a new file added to the repo. Let's see if it tells us. You see? Read this carefully, guys. I'll give you a moment. Read each of those messages. These are the errors you will be troubleshooting when you are pushing your Java code. These are the questions you will get in your interview if you say you are a Java developer. Nobody will ask you what is Java. They'll ask you, can you push it to Git? Otherwise, your code on your laptop is useless unless you can push it to outside onto a Tomcat server. It's like creating a beautiful product, but you don't have transportation. You have a bit. Let's say you bought a TV. There's nobody to bring it to your home. What happens? Is the TV useful? You bought a nice big Samsung LED or LCD TV, flat screen kind of. There is no transportation available. Will your family be interested in your TV? Instead of appreciating or saying thank you, they'll scold you. Why did you even buy that TV if you can't bring it? So Git is your transport, the code transporter from your laptop to the world. So here, I'll keep quiet, read the content for a moment. Try to understand each word. It's either English, you understood it, or it's some technical word, probably you did not understand. We will sort that problem in a moment. There's nothing that you can't understand in here. All right, let's get back. So the first two sentences, nothing new, same as earlier. It says something related to a branch called a master branch. So basically, Git is keeping all your files as leaves, and currently only the main trunk or main branch is what is available. Your current tree or your current repository is like a branchless tree. Let's search for a branchless tree. That's what your repository is. I saw. This is a tree. Oh, there are no branches. Okay, perfect. This is a tree without any branches. Or you can call it, in other words, a master branch only is available. So the image that you're looking is exactly what this message means. On branch master. There is no other subsidiary branches or secondary branches like this. So this is your master branch. What's the other word for master branch? Main branch. Some systems use main branch, some systems use master branch. Now the reason this change happened about 1 year before. Means instead of master, people have started calling it main branch. There is a story behind it, an interesting one. This refers to basically master slave model. Client server model, you guys refer to? The whole Java is on a client server model, isn't it? Right? That's where comes the front and back end stuff. And you being a full stack, you do all kinds of stuff. Yeah? Full stack developers do everything. Front end, before front end, middle end, back end, last end, all ends you will do. So the master branch basically started being renamed to main branch because of the word problem, master slave. This has references to client server architecture. It also has front end, back end. Now, the reason why we are talking about all these things is not every change that we come across is necessarily a technical requirement. Let's see why this is a non-technical requirement. I'll give you in a moment. Master slave, to pay focus or pay attention on the word slave. About 2 years before, there were protests or what we call dange, allar, in US about one of the black persons being killed. And can anybody recollect his name? There are a lot of protests in US. One of the black persons was killed by a policeman, white policeman. What's his name? I forgot. Huh? It starts with some P. Which one? What's his name? Can anybody? Yeah, guys. Floyd. Correct. Floyd. Floyd, yes. It starts with N, his name. Neil Floyd or somebody, his name. Yeah, that's correct. His name is Floyd. Let's try to get Save Black Lives Matter. That's the moment that was started after this person was killed. In India, we did not have much of movement on this because not directly related, but in the software industry, this was a big movement. Black Lives Matter. One of these guys was killed, and they started referring to this whole thing as slaves and all that stuff. Where are we? You see this thing? This is the master slave model, right? Your software. This slave thing, George Floyd. Yeah, I think he's George Floyd. His name is, yes. Thank you very much. Yogesh. George Floyd. Yeah. He's the guy who was killed by police, and people started interpreting it as a racial thing, one blacks versus whites thing. So at this point of time, all the software companies started to realize that racism is not something that we promote in software industry. All industries actually went behind it, and they stopped using this master slave word. So wherever there is a word master, they started replacing it with a other word. That's when Microsoft replaced its master word related to Git to main. So from that point onwards, this master branch that we were talking about, this master branch that used to be called so far, it moved on to main branch. But some other systems still try to use the old name itself. So sometimes people call it master branch, sometimes people call it main branch. But the reason why the name changed from master to main is because of certain protests or certain incidents in software industry. All right. Now these are some of the interesting things that happen, and by keeping track of such things, you understand why the software development happens in a certain way. All right. This is not purely technical in nature, but it's important that you understand these things because you are part of this system. You need to know, let's say you go ahead and say master slave in an interview, and you have a client on the other side. The other person gets offended. It's a serious thing for the victim. All right, so you have to be really sensitive to using your words. So, and to know that thing, you have to understand what is happening in the industry, why such a thing happen. So instead of master slave, people are calling it main branch. And a slave word, it pretty much stopped being used. Nobody should use that word anymore. It's offensive. We should not use it anymore. So all the words that you see, wherever you see master slave architecture, especially this was the original name that was given for client server architecture in distributed computing. This has been replaced with client server model or other model, except you don't use this word. So coming back to our current context, the branch that you are looking at, it can be called a master or it can be called a main branch. One of these two. So let's go back to our status, Git status. It says you're on branch master. You see, it still uses master. Ideally, it should be main branch, but they did not change it. That's fine. Again, commit, it's talking something about commit. We will see in a moment what a commit is. Then see this. We have added a new file, right? We have added it to the directory. What Git says here is, this is still untracked. Means it's saying the file is there, but I'm not tracking it. That's what it means. Means I can find a new file called new file 1, but I'm not tracking it for some reason. What is happening here is something that we have to understand. And to track it, it gives a tip also. Use git add. Most likely that's our next command. So what is happening here is, just because we put some file in that directory, Git will know that there is a file, but Git is not really tracking anything happening in. Let's add a couple of other files also. So new file 2. Let's run a git status again. You see new 2 files, untracked 2 files. Let's add a directory. So adding a directory now, or a folder. New folder 1. Let's see. Git status. What happened to the directory? It is not showing a directory, right? Why not? Let me fix that problem. I'm going into the directory. Inside the directory, I am creating a file. File in new folder 1, right? What I did, when I created a directory, when I created a directory and did a git status, let me put it right side. I'll reduce the font a little bit. Git status. You see this thing now? Now it's visible, but earlier it was not visible. Let me recreate the scenario again for those who missed it. I'm creating a directory and running a git status command. Rename new folder 2. Only folder created, right side git status. I can't see git folder 2, only git folder 1 is available. What's the difference between folder 2 and folder 1? Which one? There is a file inside it. That's correct. Everybody understood that point? Which means Git will not show the status for empty folders. It will not track empty folders. That's a very important thing. A lot of times what we do is we create the entire folder structure, run it under Git, and we're kind of worried it's not showing up in status. The reason is, if the folder is empty, you won't see anything in Git status. So here again, coming back, folder 1 has a file inside it. That's why the status is visible here. Whereas folder 2 is empty folder. There is no file inside it. That's why you don't see it here. So let's add a file to folder 2. So here I'm putting it in new file 1 in folder 2. In folder 2, let's see. All right. Now let's run a git status again. Git status. You see that folder also? So empty folders are not tracked by Git. That's a very important point. Initially, when you are practicing, you will come across this problem and you get confused why my folder is not being tracked. So let's make a note of that thing. This is a very important point here. I'm going to start. Empty folders are not listed by Git status. All right. It does not list or it does not even track them. So let's go back again. Let me close these things, all unnecessary stuff. So we're here. That's our second command that we looked at. So basically, we're working on git bash. We initialize the repo. We try to add file state and then try to understand the status. Now it's time to understand the structure of Git, how Git tracks everything. I'm going to draw 3 trees here, or 3 areas here into 3 boxes. This is box 1, let's say, copy it. Paste. Remember these 3. This whole Git architecture is on these 3. The directly you are seeing, right? So what we are here now, we are here to understand the next important thing, how Git tracks stuff, or in other words, Git architecture. Once you understand the Git architecture, everything else will be easy. All the commands will make sense then. If you only learn the commands, they won't be much of use. You won't really know why you are using a command. If you understand these 3 things, three towers they are called, or these 3 trees they are called. So the first one that you are looking at here is called working area. Let's set this up a little bit. Or it's called working tree sometimes. The second one is called staging or index. Area or tree. It can be called staging area or staging tree, or index area or index tree. Let me change this. The first one is working, second one staging, and the third one is called local repo. This is the third thing. Local repo or repository. So staging, working, and local repo. These are the three things that every developer should be good with. So when you say git command, you're essentially referring to one of these three things. These are three logical areas. What's the physical area for all these three things? Any guesses? Physically, where do they are? Where do they live? They are in your .git directory. So you have the .git right here. This thing inside this directory. All these things that you are looking at, they basically refer to three logical elements. What are those three logical things? Can you recollect? I won't show the image. Can you recollect the three things that we just listed out? You are drifting, all of you are. I think it's lunchtime. Come back for half an hour. The three verticals that I listed, anybody online? Required 10 minutes break. No, we just had 1 hour break. You're a Java developer. You should work for 24 hours a day. I'm just kidding, guys. We'll take a break. Hold on, just give me those three areas. Try to recollect. Working, staging, and local repository. All these three are logical areas and they are physically present in the .git directory that gets created when we initialize the repository. So remember these three areas: working area, staging area, and local repository. Let's try to quickly understand what these areas are. Working area is where all the work happens, means your directory. This thing. This is your Git repository, right? Leave the .git part. This is your working area. If you add a file, you're adding to working area. You delete a file, you are removing from the working area. You open file and change something, you are editing a file in the working area. What about the other two areas? These two, staging and local repository, they are basically inside this Git. Even though I said working area is also part of Git, that's only partially true. Now, let me correct that thing. Staging is here and local repo is here. Can we compare or can we link this staging area, logical area, with the directories of .git? For example, so which of these directories here under .git refer to staging area? Staging tree. Not possible. There is no clear definition of the logical to physical mapping. Means staging could be in any of these directories or across multiple directories. When you run git command, it fetches data from these directories and files. You run git status, right? What the git command did when you did git status, basically it went into the .git directory, it looked at these files and it fetched that information here and posted it here. Which means if you delete the .git directory, the git commands will not work. As happened. So the whole git command depends on this .git directory to fetch the information. So the storage is in .git. The git command is only doing the processing of the information. So whenever you run a git command, It goes into this directory, tries to find out what is inside these directories, and lists out onto the screen in a proper form. So in here, the three logical areas, out of the three logical areas, a staging, otherwise called as index area, is part of this .git directory, and also the local repository. Now let's try to understand what is the purpose of each one of them. We already know what is working area. Working area is basically your directory. This is the working area of your Git repository. This is where you create, delete, modify your files. Only three operations. Or you can add directories and add some files into those directories. A second one, staging or index, is related to the second message that we are seeing. You see this thing here? It says untracked files. The keyword here is untracked. That means Git knows about the existence of the files. Git knows that these files are there, but it is saying, I'm not tracking it. What does that mean? If you know, you are tracking it, right? No? Or you just know and you're not bothered about what is happening inside those files? What does that mean? That's a very minute, conceptual thing. If I say, let's say, I have a friend, Ramesh or somebody, I say, I don't know Ramesh, or he's my friend, I don't know. You are in a way indirectly saying that you know that person. You are saying you're not tracking that person, or you don't know what's happening with that person. That's what is happening here. Git has already listed those things, but it's saying I'm not tracking. This message is because of these two areas. Let's go back to the areas. You see here, Git is looking at working area and it's saying, yeah, there are 2 or 3 files. I can see those files. But what is happening in those files is not tracked, because for Git to track what is happening, it has to look inside that file. And you need to tell Git to track. And how do you tell Git to track something? That's your next command. What's your next command? That's our third command.
Add.
Git add. You add a file to Git staging area. That's when it starts tracking. Working area, it knows that you have created a file, but it does not know you want to track it or not. So here is the tracking happens. So you need to tell Git to pick a file from the working area and start tracking the changes. So when you say that, and how do you say that? You say git add file name. When you say that to Git, it moves this file name, or it adds this file name to staging it, or staging tree. So you have one tree here with all the leaves. Each file is a leaf. Then you have another tree here. The leaves will be formed when you run which command? Git add. So every time you do a git add, logically things are being tracked. So it says, okay, you want me to track something? Fine. I will keep track of this thing in my staging area or index area. It will tell you whether I'm tracking or not. So let's go ahead and add one of these files, which is in our working area. We tell Git to track it. Therefore, it starts adding it to index. Now remember one thing, these are logical blocks. You won't have any file movement on the directory level. The directory still looks the same. Let's go back and try to do that. So here, I'm going to add one file. Let's run that git status one more time. Let's also look at the working area. This is a command, and this is the directory structure. Where are we? Where is it? Yeah, sorry about this. Oh. So on the left side, you're looking at the folder structure, and on the right side, we are executing the git commands. A third command, we are trying to execute git add. Git add a file. So when we add a file, what exactly we are doing? We are not physically adding anything. We're adding to the git tree structure, the 3 columns. So we are saying git add one of these files. Let's pick up any one file. Remember, none of these are tracked. All the 4 files we are not tracking. We will add only one at this point, not all of them. Means you can choose to track some of the files in the Git repo, leave out the other set of files. All right. So just because you initialize this repository directory, everything in this directory need not be tracked. Some of the files in this directory, you can leave it. Means complete control is for you. So I'm going to add one file, git add new file 1. All right. Enter. It added, it did not tell you anything. Now let's look at the status to understand the structure. Git status. What's happening now? Read this message again. Take a moment, read this message. Try to link it with the 3 spaces that we created, 3 verticals. Really try it, you will understand it. Don't wait for me to explain. Compare the earlier message to the current message. Before the git add versus after the git add. All right, let's see what happened here. So the first one was before the git add up to this point. And the key point here is there were 4 files, 2 files and 2 directories recognized by Git, but not tracked or untracked. Then we asked Git to add this. When we say add, what it did, it basically added it to index area. That is the tracking area. So every time you add a file, you are basically asking Git to start tracking it. Then we did a status again. Now it's telling us there are changes to the staging area, but they need to be committed. We will see in a moment what is committed. But look at the list of untracked files. Did this change compared to earlier one? Compare it with this thing. Earlier, there were 4 untracked folders and files. Now, only 3 because we have added 1 to the index. Means we told it to track one of these files here. So we add a file. Let's look at the flow here. We add a file to the directory, or we simply create a new file. Let's declare that thing. So we create a new file anywhere in your directory structure. Let's call it, let me create a file. New file 3. This time we created a file on physical structure. At this point, Git is not tracking it. You can look at the status. So if you say Git status, it's not tracking. It clearly tells you I'm not tracking it. You see, I can see that in the list, new file 3. This is the file that we created just now, isn't it? Now for Git to track it, what should we do? Git add, let's add the newly created file. All right. Now run Git status again. You will see tracked files, untracked files. So in the repo, there are 2 files which are being tracked. There are 3 files and directories which are not being tracked. Let's keep it like that. Look at the most important things. Next vertical. Changes to be committed. That's the third and most important point. Let's go back to our diagram, the 3 verticals. What's the third vertical? Our third tree. A local tree. You see this thing? Local tree or local repository, it's called. Instead of local tree, it's usually called local repository. So when we did an add, we got files here. So what are the files we have listed here? New file 1 we have added, new file 3 we have added. We did not add 2. And in the working directory, you still have other files and directories left. New file 2 is still left over there. New folder 1 was still there. New folder 2 is still there. We are not tracking them. Now, you asked Git to track these files, and it said, yeah, I'm tracking. It also acknowledged that these 2 files are currently added to the staging or index area. That's what your Git status command. Now, if you have to track the changes, the file is created and it has to be stored somewhere permanently, right? That's how Git tracks everything. How does Git know your version 1 till version 10? It's not that intelligent. It's a stupid tool. Instead of you keeping copies, it is doing it for you. It's not artificial intelligence. It's a simple program. It does not know anything. It has to store it somewhere. But for it to store, you need to tell it to store. That's your next and most important thing, the Git commit. So when you say Git commit, your file and its changes get stored into this vertical. It basically takes a zip file compresses it extremely. It's called a blob. I'm sure you are familiar with this type of object. You'll learn it in your databases. Usually it's their starts. Now the blobs are into programming also. So a blob is basically the same text file that you have created here, but in a highly compressed format. Binary object or big object, some people call it. Just usually binary. Binary large object. All right. So what is happening here is, look at the flow. You create a file, then you say git add, it comes in here. You are happy with all your changes, then you ask Git to store it. When you ask it to store it, it zips it, stores it somewhere inside that .git directory. So in this whole process, is Git doing everything or you are the one who is doing everything? It's not like you're doing the changes and it's automatically doing everything on the back end, right? You are telling track it by executing a command, git add. Then you are telling store it by executing the command, git commit. Next, we'll see that. So your decision of what code you want to store, what code you don't want to store, what Java file you want to permanently zip it and store, it's all in you. That's the reason you need to execute these commands again and again during your work. So these commands that we are talking about, let me store it. So these 5 commands that we keep talking about, these commands you have to execute. You have to do a git initialization so that you tell Git that, okay, start tracking. Then you have to understand what is Git tracking at any point of time. Show me the status. Show me what is there in the working area. Show me what is there in the staging or index area. Show me what is there on the local repository. That is your Git status. Then git add. You're saying, take this file, start tracking it. So basically it moves from the work area to staging area. Then the next command and also the thing that we discussed, git commit. Git commit is basically telling Git to, boss, now I'm happy with all my changes. I've written this beautiful code. I want everybody to know about this thing. Let's keep a copy of this beautiful code I've written. So that's when you execute a git commit. Sorry, that git commit, and your file goes from here to local repository. Let's go ahead and execute that command. Let's see how it looks like on your command. So let's go ahead, show this thing. Keep a watch on the working area also. While you are executing all these commands, do you see any changes in your directory? That's the most important confusion a lot of people have. Everybody thinks when you run a git command, something will happen to your directory. Nothing will happen. Everything is happening inside the .git directory. You don't know about it. You don't have to know about it. That's the beauty. You just work on your directory, just like you are creating your files, you are deleting your files, or you are modifying your code, Java. That's it. You don't really care about the Git until you're trying to store something or add something related to Git. So come back here, Git status one more time. We are tracking two files which are added to the staging area, and we are not tracking these three. Let's leave them aside for now. Now these files or these changes, they should be committed, or in other words, stored. And where do they get stored? In the local repository, somewhere here. So there is a zip file that gets stored somewhere inside this .git. Don't worry about where it gets stored unless you really want to be an advanced Git user. You don't really need to. Now let's come back to our command. What's the command? Git commit. Now, when you say commit, you don't have to tell which of these files you want to commit. Everything in the stage will be committed. That's the whole point. Means everything that you are tracking in this tree staging. Where is our image? This is our image. Let me store it. Let me pull it here. All right. So git commit we are executing so that anything that is on the index already will be permanently stored into the zip file. That's what we're doing here. So let's go ahead and execute the git commit command. Git commit. Now, when you do a git commit, there are a couple of things that you should give to the git. Let's try to run it and see the errors. You'll understand what it is trying to do. Oh shit. Something else is happening. Failed to delete database IOR, waiting for your editor to close the file. Somehow it linked to my VS Code. This was the result of messing up I was doing yesterday night. Anyway, it opened this file here. See this thing? This is the same file. We don't want this thing. Don't worry about this. Let me get back this. Let's look at the error. Don't worry about the VS Code that is open. It aborted for some reason. This is important. Why did it abort? Empty commit masks. The requirement with the git commit command is every commit should tell what this commit is about. When we say commit, what we are doing essentially, you are basically storing everything from the staging area into local repo, right? Now, when you do this, you need to give a short message of what this whole change is about. Let's say you changed one of these Java files, the hello world, your system println, you changed it like here. Where is it? Let's say you change your hello message and you are committing this welcome class.java file. During that commit, you have to tell that I am changing something like this, so that when you look at it again over a period of time, you will understand where your file is, and that is usually given in a commit message. So here, when we are storing these changes to the local repository, we have to tell what these files are about, something related to it in a message. Let's try to give that. So git commit You will give a message using -m. Give any message. What is this about? What are these two files about? What did we do? It need not be technical. It is not a programming. You can give any message you want. If you recollect, we simply tried to add these files. That's it, right? We did not do anything, any code, no code, nothing. We did not do anything at all here. We tried to create new empty files. That's it. And that's what we're going to give in the message. So here, commit new empty files created. Right? Enter. Something happened. Looks like. Let's see what happened. Let's read these messages. Master root commit with some hexadecimal number. New empty files created. That's your message. 2 files changed. 0 insertions, 0 deletions. This is important, guys. This is something that you will keep looking. 2 files changed. These are the 2 files that we were talking about. New file 3, new file 1. In these 2 files, it is listing out what is actually changed. 0 things were inserted, 0 things were deleted. What does that mean? Means inside these files, only 0 times things are inserted. Means nothing is actually inserted into those files. 0 deletions. Nothing is also deleted. Basically, in other words, it's saying these are empty files. And then these are the 2 files it created with these file permissions. These file permissions are Unix based permissions, read, write, execute permissions. Don't worry about those things. For now, this is the most important thing for you. And this is the ID of the commit. So what we did just now is, by giving this command, you have stored the 2 files into the local repository. Look at the flow, and this flow is more than enough for you most of the times. Let's write down the flow. Probably this is the summary of today's session. It's going to be the 3 or 4 things that you do to take your code and store it for the whole version control thing. So you initialize Git using git init. What is this? So initialize Git using git init. This is basically when the .git directory structure gets created. Then what you do after initializing, you add, remove files from your stuff, from your directory structure. Then add files, directories to your folder, right? Then what you do, you check the status. Then you do a git add file name. This is basically where you tell Git to start tracking something. Then you finally commit everything from the staging into local repository. That's it. So we covered 4 commands: git init, git add, git status, and git commit. So your marvelous code is locally stored now here. Is it available outside to your friend? It's still in your local laptop, right? Let's say you are sitting in your home or your PC and you are writing all the code. It's still in your laptop. Even though you are connected to the internet and all that stuff, but it's still in your laptop. You are tracking all the changes. That's fine, but they're all in your laptop. The code is in your laptop. You have to take it to outside. You have to give it to your team members so that your application code gets integrated with the other application code. For example, let's say you are a front-end developer. Let's go to Amazon or somewhere. Let's say this is a website. You are part of the development process, and you are simply developing one of these things. Let's say a shopping cart. It's the cart that you are working on, not everything. You don't work on the whole application. The Amazon.in application that you are looking at is a pretty big application. One of those modules of that application could be a shopping cart. And to implement the shopping cart, you've written nice, beautiful Java code, which is here. But this whole Java code is useless unless that code gets integrated with the whole other things happening on the website. Yes or no? Maybe there are some 100, 200 developers into 10 different teams. Each team is working on a different module. You are part of the team that is working on shopping cart module. Development teams are pretty big usually. You have to create a lot of things, then you have to change a lot of things. So assume your code is something related to the shopping cart and you are a member of a 10-member team. Now, for your code to actually come to this website, first you have to send your code from your laptop to your team, right? Yes or no? First, your team will check whether our teammate has written proper code or not. Once they are convinced that, yeah, this guy is a superstar, he has created wonderful code, then they'll integrate it with the other 9 modules. Yes or no? After that integration is done, it will go to the end user, which we are seeing on the screen here. When we click on Amazon, you are basically looking at the live website, or it's called production. Whereas the code that we are talking, the Git thing, is on your laptop. It did not reach your friend also, your team member also. But here is the important point. Even when you are doing everything on your local laptop, you still can use Git to track the changes to the whole directory structure that you are creating as part of your Java project. Your Java project pretty much looks like this. This is the Eclipse interface. This is all your Java project. I just added a couple of them. These are all your Java projects. On the left side bottom, if you see, Hello World is one such Java project I have added. Right? And out of this Hello World Java project, this welcome class.java is this, which you are seeing the code here. Now, obviously, when you are writing on a big module, how many Java classes you will have? Give it a guess. Thousands you will have. Maybe you're not dealing with all the thousands, but in your plate, you will have at least 100 classes. You will look at all those 100 classes in this nice interface here. You read that code, you make changes to that code, and whenever you do that, it all goes into which directory? Your source directory here. It's all you. Git is not outside you. You're already doing it. So when you're doing all the changes, you still use Git to track everything. And the 5 commands that we have learned are the commands that you will be using locally to do all this stuff. Now, let's say you've written all nice code for a couple of days, a week or so. Now you want to send it to your friend. The easiest way is you can bundle this entire thing into a zip file and send it to him. Create a zip file, that should do. I've created a zip file. Can I send it to my friend? All the code is in there. Would that be an efficient way to do it? I simply created a zip file of the repo that we are dealing with. If I upload this zip file into G drive, would that not be more than enough? He will download it or she will download it and extract it, then import into their Eclipse and look at the code. Fine, right? That's it. That's how simple. You both are working in the team. What happens about all these 10 people who are working in that team? You're not the only one working, right? So let's say there are 10 members. Let's try to visualize it. There are 10 members who are working on a project. Each one of you is working remotely. You're sitting in Hyderabad, your friend is sitting in Bangalore, somebody else is sitting in Mumbai, somebody is in Delhi, and somebody is in Kolkata, somebody is sitting in Europe, and somebody is sitting in New York. Everybody is developing their code. So that person has to send the code. This person has to send the code. This person has to send the code. This. So all of you can upload it to a directory, G drive. How many files will be there on the G drive? You have one zip file of your own. The other 9, they will also upload their zip files. So how many zip files are there on day 1? 10, including yours. Day 2, tomorrow's code will also come. 20 zip files. Day 10, 100 zip files. So far, good. Now, somebody picked up your zip file, right? Your friend extracted that zip file into his Eclipse and made some changes. Zipped it again and uploaded to this G drive. How many zip files you have now? Plus 1, 100 plus 1. Let's say another guy did a bug fix on your code. He said, no, there is a slight mistake here. We'll have to change it. So how many zip files you have? Let's say everybody has changed everybody's code. How many zip files you have? You learn probabilities, right? Permutations, combinations, NCR, NPR. You see what is happening? As the team grows, there are 2 problems here. One is a team is big and it's growing. Second thing, they're not working from one location. They are spread across everywhere. It's not like, you're sitting next to each other and you can solve the problems just by going to the disk. You are sitting somewhere. You are here in Hyderabad, somebody else is Bangalore. You are simply uploading your files. Extracting those files into your Eclipse is a painful process. Even if you manage to extract it, you can't really compare those changes. And you are bundling the whole project from your Eclipse into your zip file. Means there are unnecessary things also you are sending. There is no way to track only changed files. You can't do that. Now visualize it to a much bigger picture. Assume everybody is sitting in this room. There are about 30 people. You're all a team. You're all sitting here with laptops and writing your nice Java code in your Eclipse interface. Every 1 hour, you are zipping it and sending it to Jdbc. What happens? Then by the afternoon, your team lead came down and said, Anil, download everything from G drive, see where the changes are. Let's fix it by evening. What will you do? Resign the job? So the problem is there are too many changes to track. So this zip file system is not going to work. It was used once upon a time. Because of the problems with zip file, Git was developed. The Git solves that problem. You don't have to do a zip and send it. Instead, you can send a similar thing, your local repository this time, because you have everything already tracked. This is local repository, you're saying, right? If something is local, what would be the opposite of that thing? Non-local.
Remote.
Yes. Local, non-local. All of you are familiar with that word. From a software perspective, what would be the opposite of local?
Remote.
Global. Yeah. That's correct. That's good. That's good. So local, global. So we are having a local repository here, and we want to make it global or non-local. What's the purpose of such operation? Why do we want to do that? We want to send the beautiful code that you have written to your team members so that they can check your code, they can integrate or add their code to your code so that your whole module becomes operational. And that module has to be integrated with other modules of your application. And any development team usually has at least 20 to 30 people, minimum, at the beginning of application development. Once the application starts developing after 1 or 2 years, the development team size usually comes down to about 5 to 7 members, because by that time, the application is already developed. Only minor changes need to be done once in a while. But otherwise, any application that is actively getting developed, take all the popular applications or websites you normally use, Flipkart, Amazon, Swiggy, your Zomato. These are extremely active applications. Every day you see the changes, which means the development team behind these products is extremely big and extremely active. Sometimes it happens, they see an error on the screen, you see the same error, within 1 hour the error gets fixed. Means somebody made a call that there is an error to the developer. The developer opened his laptop, quickly changed a .java file, did a Java C, compiled it, run a Maven build to create a jar file, send it to a Tomcat server, and again came back and checked on the application. How long you think it took? At least 3-4 hours, or if it is happening in 1 hour, it means somebody is working extremely aggressive. There is a team behind. Means the moment there is an error, there is an alert that gets triggered. This app gave this error, 404, 502, 303 error. That alert goes directly probably to, as an SMS, to the developer, the main developer. Is probably a team lead or somebody. The team lead calls his most important guy. Boss, we got a problem. That guy has to take out the laptop quickly, see what the problem is. If required, fix it, compile it, do the basic testing, your unit testing and other stuff required, send it to the Tomcat server, take the approvals, send it to the production server. So developers are extremely active when you are working for a startup or when you're working for a big aggressive company. That's the whole reason you're so much in demand. Application development, you're seeing all the Swiggy, right? Every day you see a new thing on Swiggy. Who is doing it? You are the one who is doing it. And it's happening really, really fast. So your code, which is currently locally available on your laptop, has to be made global. Now, instead of word global, let me use another word called remote. That's a word that gets used. So we are here locally up to this point. This local repository, Git repository, we'll try to make it global, or the more appropriate word, or the industry standard word, remote repository. And that's your next session. We're going to see your GitHub. So your remote repository is GitHub. It's more like a G drive, but little better. It has more features. So github.com is a website that acts as a remote repository. All that you're doing is you're sending your code to the remote. And how do you send it? That's your last command, I think. Git push. It's a very simple command, right? Makes sense. It's English. So on GitHub, your entire repository goes in. Just like GitHub, there are other websites also that can act as remote repositories. Any guesses? Anybody knows any such things? There are GitLab.com, very popular one. It also acts as a remote repository. Then Bitbucket.net, I think it is, or whatever it is. Bitbucket is another website that can allow you to create remote repositories. So when we talk Git, do not think something is happening on the cloud or somewhere else. Your Git is all happening locally. It's all on your laptop. Your Git init happening on your laptop. Git status, you're just tracking all the things on your laptop. Then Git add, you add it to the index. Then Git commit, you add it to local. And finally, you Git push. That's when your code moves out of your laptop into a cloud server, or in other words, it's called a remote repository. So that's a website, github.com. So somehow we have to bring our code that we have written here, not in a zip file. So I'm going to delete that zip file. Not in a zip file, guys. We are not using zip anymore. So this repository that I have created, which is currently available locally, I need to bring it to this website. Let me exit out of this thing. so that you get a good look at the website. This is the remote repository website. We're going to create our repository and bring our code onto this website. But once we bring it to this website, your team member is going to use the next command to get it to their laptop. So let's say your team member is sitting here somewhere in Bangalore. You did a git push here. So your command is git push. So your code is sitting here on the remote repository. Now your friend needs to take it. His laptop is this thing. What your friend should do? What should be the command? Git pull. Make sense? You are pushing it, that person will pull it. Which means we'll have to learn about what this is, how this is structured. And once we understand that, how do we push this thing? And once we understand it, how somebody else will pull my request. In between, there is another step. Our team members have to accept our code, right? In other words, it's called merge your code into their. So we have to understand what is merging process. How do we do it on GitHub? And what happens during that merge process? That would be our next session. So right now, I think we are way beyond what I thought we would be able to cover. Completely, we could not reach that stage. So I'm going to have another session, probably next weekend or the other one. We will try to cover this part during that next session. Would that be okay? If I do it now, it will be more like too much hurrying kind of. And GitHub is interesting. So we will do it next week or the week after. I'm not sure yet. I'll look at the schedule. Any week is okay. Next week. That's one thing. Second thing, these timings are okay, or we should change the timings?
Sunday better, sir. Sunday we will
Change the timings.
Yeah, either Saturday.
10 to 1, we can't cover anything. We started at 8, still we could not do much. We need at least 4 hours. Out of 4 hours, 1 hour will be wasted. So effectively, it will be 3 hours. So any timings, I think online guys are really happy with it. You don't have to take a bath. So offline, 8 to 12, 4 hours, we will stick to 4 hours, not 5 hours. Maybe we can move to 9 to 1 if you want me to move it. Nagur sir batch, sir, right? So I'll have to talk to Nagur sir. If I ask him to cancel it again, he will say, no, you cancel the Git. But he is very supportive in that, that you guys should know Git at the beginning of Java learn. By now you understood Git has nothing to do with Java. Sorry? You want to talk? So Git has nothing to do with Java. Git can be used by all programming languages. Even without software, you can use Git. But if you know Git at the beginning of your programming learning journey, you try to use it during this learning. Means when you are doing CoreJava, you use Git and store your code on GitHub. When you are learning your advanced Java, or when you are learning your Spring Boot, anything, your web services, anything, whatever you do, everything you can use Git. So what happens is, if you are learning this whole thing about 6 months, your Git understanding is actually happening over 6 months period. So you will be much comfortable with Git by the time you are ready with your Java end. Otherwise, what normally people will do after your Java, you start Git. You won't be comfortable. You tend to think Git is something outside Java. No, without Git, you can't touch Java. Forget your code. It's like you bought your TV, that's all. Can't watch it. Nobody wants to watch it. They can't. There's no transport available. So you being learning Git, Nagur sir was really supporting this thing. Let the students learn Git. If they can learn Git, other trainers can integrate Git into their process. Let's say Nagur sir is teaching you CoreJava, simply he wrote a Java program. Let's push it to GitHub. And if you know GitHub by then, you're actually doing something that is done in real time. Yes or no? Your learning can happen real time right from day one. Just because somebody is sitting in high-tech city, they're not doing rocket science. They do the exact same thing. You executed the same 5 commands that we execute. We do it every day. I do it every day. The same commands, nothing different. But little bit before, little bit after, how do you order your learning makes a lot of difference. For example, Jenkins. Jenkins is just a tool that will run your Maven build. Now the question is, when should you run your Maven build? Now or after you learn RESTful API? You can run a Maven build now on CoreJava. Yes or no? You can run a Gradle build now on 10th day of your Java learning. The same Gradle Maven build is run by Jenkins. If you know Jenkins now, you will be doing your project work right from day one in real time way. That's the idea. That's why it was really supportive about it. So again, coming back to your session, most likely it will be Sunday, like some of you have suggested. We want to finish it quickly so that we don't forget what we have learned today. All right, that's one thing. Most likely next Sunday. Is Saturday okay for this type of sessions or only Sunday? Saturday, so you have regular Saturday sessions, you don't have? You have regular Saturday sessions also. So it's usually 6 days a week. That's how it works, or 5 days a week. 6 days. You're learning too much hard work. When are you taking rest then? Even on Sunday you are sitting here. You're not taking any rest, you're saying? What did you do last? What are you doing in the nights? You're studying? No? Netflix. Somebody said Netflix. Netflix or Amazon Prime, AHA. So we'll try next Sunday. Sunday seems to be more appropriate for most of you. Sunday, and the timings maybe we will push it to 8:30 to 12:30. That makes sense. All right, and we will try to cover most of the GitHub and finish everything in the next session itself. So we don't extend beyond 2 sessions. All right. So that's all, guys. Thank you very much. You can disperse. Thanks for being patient for 4 hours. So I'll see you most likely next Sunday. Yeah. The session is recorded, guys. Or it'll be available for all of you. You should get a mail in a couple of hours about the recorded session. If you have any questions, let me know. Post it to the chat. Thank you very much, guys. రిమోట్ లో GitHub లో పుష్ చేస్తాం. Hmm. Hmm. Hmm.
మన దగ్గర ఉన్న కోడ్స్ అనేది అందులో కూడా చేంజ్
అవ్వు నీ ల్యాప్టాప్ మీ ల్యాప్టాప్ ఇక్కడ అవ్వదు, ఏది అవ్వదు. సో ఇప్పుడు మీ కోడ్ అంతా ఇక్కడ ఉంది గిట్హబ్ లో. అతను డైరెక్ట్ ఇక్కడ చేంజ్ చేయలేడు, తను పుల్ చేసుకుంటాడు. పుల్ చేసుకొని చేంజ్ చేస్తాడు కదా, అది చేంజ్ చేసింది మళ్ళీ నువ్వెలా చేసావో తను పుష్ చేయాలి, అప్పుడు మళ్ళీ నువ్వు పుల్ చేసుకోవాలి. అంటే ఎవరిది వాళ్ళది లోకల్గా ఉంటుంది. ఏదైనా చేంజెస్ కావాలి అంటే సెంట్రల్ నుండి తెచ్చుకోవాలి మనం. నీ దాన్ని ఎవరైనా చేంజ్ చేయాలంటే నీ దాన్ని వాళ్ళు పుల్ చేసుకోవాలి. సో ఎవ్రీథింగ్ ఇది నీ ల్యాప్టాప్ అని, మీ ఫ్రెండ్ ల్యాప్టాప్ అని. సో మీ ఇద్దరికి డైరెక్ట్ కనెక్షన్ లేదు. దే కాంట్, యూ కాంట్ టచ్ హిస్ ల్యాప్టాప్, హీ కాంట్ టచ్ యువర్ ల్యాప్టాప్. ఏదైనా చేయాలి అంటే నీ దాన్ని పుష్ చేయాలి సెంట్రల్కి, తను నీ దాన్ని పుల్ చేసుకొని తను చేంజ్ చేసి మళ్ళీ పుష్ చేయాలి ఇక్కడికి. దాన్ని మళ్ళీ నువ్వు పుల్ చేసుకోవాలి ఇక్కడ, అప్పుడు తను చేసిన చేంజెస్ నీకు కనిపిస్తుంది. సో ఆ రకంగా లోకల్ రెపాజిటరీలో కంట్రోల్ అంతా కూడా ఎప్పుడు నీకే ఉంటుంది. అన్లెస్ యు ఆర్ హ్యాపీ విత్ యువర్ చేంజెస్, నువ్వు అక్కడ పుష్ చేయకపోవచ్చు. లేకపోతే కోడ్ రాస్తున్నావు, ఉదయం రాసావు, సాయంత్రం అదే కోడ్ చూస్తే నీకే చిరాకు నేను మార్చేసాను మొత్తం, అప్పుడు నువ్వు పుష్ చేయలేదే. మధ్య రాకుండా స్టాక్ ఓవర్ఫ్లో కంప్లీట్ అదే అందులో కొన్ని కామెంట్స్ ఉంటుంది. సాయంత్రం కదా సాయంత్రం. సో మార్నింగ్ నువ్వు ఏదైతే కమిట్ చేస్తావు ఈ కోడ్, అది పుష్ చేస్తావు అవసరం లేదు, దాన్ని రిలీజ్ చేస్తావు. అంటే ఈ లోకల్ రెపాజిటరీలో ఉంటావు, కానీ అది సెంట్రల్ రెపాజిటరీ, రిమోట్ రెపాజిటరీ పంపించే వరకు దాన్ని ఎవరు చూడలేదు.
హలో హలో
Developers, you need Git, GitHub, Jenkins, Maven, and nowadays Gradle. Yeah, I'll come there. I'll come to the testing part. We are still in Java. After Gradle, I'll put in the same order that I'm listing. Jenkins, first GitHub. GitHub. Then you will need Maven and Gradle. Sometimes nowadays Gradle is the middle. Something Gradle and Maven. Some people use Maven, others use Gradle. You know one, the other is also fine. You know both, will help you. Then Jenkins, that's where your own brain runs. Then you have to test. Yeah, you test. You have to do it. Nowadays, all the unit tests, to developers. So you have to do how many tests? Yeah, you need that. Or maybe Cucumber, if you know Cucumber, it's okay. It's manual test. Automation testing majorly, but Cucumber is also a very simple tool that allows you to write simple JUnit testing. That's not mandatory. Just stick to JUnit for now. After JUnit, you don't need, you have to be good with some debugging and tracing tools, but not to log. Which one you are using now? What is log? But CoreJava is okay, but you need to probably pick up another one. But that's not really a critical element. If you are good with the first 5 things that I listed out, then only they will ask for log level point. Let's say you stumbled at Git itself. You don't even know Git. You don't know log if you are not using log. You need to learn things that are most important to track the entire system. The most important thing you already have that. We can focus on these areas and you can present your learnings in a confident. Now when I say present text, it has nothing to do with English. Let's say you want present in Telugu or Hindi, Can you can you tell what you speak in your mother tongue? That's okay. It's very required. It's better. Say you are speaking in Telugu or Hindi. हिंदी में अगर इसको समझा रहा है भाई गीट है एक बार चेंजेस कर चेंजेस करना है दस देने से 20 देने में सब कुछ ध्यान है काम कर दो इस समय काम करने सब कुछ मेरा काम ईमेल इसको करने मदद को देना केवल हम टेस्टिंग करेंगे अपना 2 मिनट निकाल के ये टेस्टिंग करेंगे फिर बात करेंगे जो दो एबिलिटी टेस्टिंग that has been done on the loop आई तो वहां पे GitHub से प्रोजेक्ट हमारा कोड वहां अगर बिल्ड रन होके टेस्ट होके फेल हो गए then there will be too many failures usually what teams do is you have a local testing environment वहां टेस्ट पास होने के बाद GitHub that for testing JSP test about nowadays we are pushing code quality test also sonar cube then there is a other test called secret scanning test जैसे कि अभी आपको पासवर्ड आप करें तो मैं डाल पासवर्ड डाल तो जाके GitHub में बैठे सबको बता सिक्योरिटी ब्रीच तो क्वेश्चन वहां भेजने से पहले हमें पता होना चाहिए कि हमारे कोड का पासवर्ड you don't understand it let me say so you have to know even before you send the code to GitHub that your code does not have this password first when you accidentally store your password file also into the repo and you delete it then you delete it everybody knows your password that's the security risk that is your personal password, okay. But if it's let's say company's account password and application password. So what nowadays is happening? Your passport scan tools are something called couple. You won't need to scan your code because it's all text. So it checks your entire record with your code. It scans the code and finds out the password looking kind of thing. And if it thinks that it's a password, your field fails, your parent field. Because your field fails, you want to you will test. And the thing will tell you this what the problematic code is in this file. Now you go to the see and look from the code I will make your change. To make comment question. I will comment. Right?
Hello. Hello. Hello.
Reference reference కావాలి సబ్జెక్ట్ నేర్చుకోవడానికి సబ్జెక్ట్ నేర్పించే వాళ్ళు లేదు సాఫ్ట్వేర్ ఎలా జరిగింది అంటే అంత నేర్పించగలిగేవాడికి ఆపర్చునిటీ చాలా 80% అంత అలా